All right, time to start. So, welcome everyone to our webinar organized by GetinData. The webinar will be about the complex event processing, how we build platforms that realize that realize stream processing as well, and that handle, I would say, millions of users and billions of events generated by these users, mostly in real time, but not only. My name is Krzysztof Zarzycki, and I'm a CTO at GetinData. I'm also one of the co-founders of GetinData. Personally, I'm very passionate about what I'm going to talk about, and I hope that I will share this passion with you as well. Okay. Just a word about us, GetinData, that we are here and talking to you. So we are a company that generally helps companies become data-driven, or becoming digital natives, I would say, sharing, or I would say being inspired by very large digital natives in data processing. We ourselves, the founders of the company, worked at companies that were pioneers in large-scale data processing, like Spotify, like Netezza or IBM. And that's where we fell in love in this. No, actually, we fell in love a little bit earlier, but I would say that we even increase this love in big data and in big data technologies. And then we started a company that we wanted to be focused on big data and cloud from day one, to share this passion, I would say, with the world, and use our knowledge, of course. Now we gathered together over 50 engineers, all focused on big data as well. So we have very strong profile, and of course we are building that with community as well. We are helping the community, giving back as much as we can, and we, for example, organize one of the largest in Central Europe conference around big data in Warsaw. I invite you very warmly to next edition, which should be somewhere around February. Big data, of course, is a very generic term, but I would say that we mostly focus on using open source technologies, which are prominent in this world. Some of the technologies I listed below mixed maybe with clouds as well, but of course, there's tons of technologies which would not fit the slide. And we combine those technologies to solve many classes of problems. One of the classes is the one that I specialize in, which is stream processing. And this is the subject of our talk. So, but before I get to it, let me just shortly define what stream processing is. Of course, not very like mathematically or anything like that, but just in one sentence, if I was asked what the stream processing is about, right? It's a paradigm. It's a way of programming applications that work continuously, accept data continuously, and produce results continuously. Usually they accept a stream of data and output a stream of data. That's actually all about it. It's nothing revolutionary here. But of course, around this idea, there's a lot of problems to solve to make this practical, and this is where the technologies around stream processing are, I would say, helping us with that. But why this concept itself is important for the business? In this presentation, I would like to address the needs of people who are less technical but more business oriented, as well as more technical people that are more focused on the details. So I will try to mix and match, I would say, the content to both groups. But so definitely, why is it important for business? There is, and it's often one of the main things that stream processing brings, not the only one, but the main thing that stream processing brings is the possibility to process data in real time. But before I say what I mean by that, let me say only that now more and more data in the world is being generated continuously, right? It's being continuously generated by devices we wear, by machines in manufacturing. It is being generated by cars that we drive. And there is more and more need to be able to process this data, not only in real time, but the real time is the most, I would say, valuable. Why? Because this, the real time is the moment. I mean, I would say that the data, the insight that we get from the data is most valuable when it's extracted just after the data has been generated. So the insight is actionable, we say, mostly, in very short time after the data is being generated. Of course, there's a lot of use cases for just gathering data and make it available for analysis and make it actionable, I would say, in this sense, but more for strategical decision making, right? For I would say driving the company in general, making the direction of the company. But there is a lot of potential in data to make it actionable for operational purposes, for creating new products, for value of the product, I would say, for reacting to the market, to saving the cost, and many other ways we can, I would say, extract value from the data, but only if we react very quickly after we get this data. And that's why the concept of real-time processing is now extremely important to make these actions, this actionable insights on the large scale, because strategical decisions are done rather rarely, but operational decisions are made hundreds of thousands of, even hundreds of thousands of times per second. They can get to that level. And now getting back to stream processing. Stream processing is probably the only way, if not the only way, to actually be able to implement real-time processing. That's why I believe stream processing is so important for business. But is it only for business? No, it is also important for engineering, for the IT, for technical people. And of course, implicitly, anything that is important for engineering is also in some ways important for business, because that brings agility, that brings cutting of the costs, and so on. But focusing now on engineering, why stream processing is so important? Because it actually is a whole paradigm, I would say, that makes definition of the applications that process data much easier to express. Why it's much easier to express? Because it's just natural that data flows now, right, from those devices, from users, continuously. It's continuously being, arriving, I would say, in our backends, right, in our systems. Even if they arrive in files, they arrive every day. There is a file, so there is a continuous stream of the files. Of course, for a long time, this process was being solved with batch processing, but I claim that with stream processing, this might be even easier to solve. Why easier? In what cases? I just want to bring one, which is, imagine, for example, calculation of the, I would say, aggregation of user sessions, which means like stream of the events that single user do, and we would like to calculate like for how long he was listening to the music on a system like Spotify, for example. These can span now not minutes, but hours or days. And now what batch boundary we would need to put to be able to actually have all the data at hand to be able to calculate this aggregation, these user sessions. Whatever we put, there will be a session which span over those batch boundaries. That's sure. That's for sure. So the solving cases like that in batch is possible, but it's extremely. But it is either expensive or hard to realize. So we did a lot of things like. A single data point actually might be processed multiple times because we are using a sliding window that looks at each data point actually over time, multiple times. Or at the batch end, we might produce some partial aggregates, partial accumulators, and save them somewhere. But making that is tedious and especially hard to express in the high level languages like SQL. So with stream processing, instead, these kind of things can be expressed very easily because there are no boundaries. There is in the stream processing world, we can actually for each user, I would say, keep the window as long as we want, for example, for days. This is one of the aspects, but there is also, I would like to now zoom in at the one class of the problems that are effectively solved with stream processing, and that is complex event processing. Complex event processing is around analyzing, I would say, patterns of the in the events. It's about finding relations between the events in the stream, finding what the cause and the effect of that cause, and analyzing that. For example, reacting on when some patterns occur, or just calculating how many of those patterns have occurred. But it's not only about that. It's also about inferring higher level events from the low level events. With the low level are rather technical. For example, these are logs from our network in a telco environment, while business relevant higher level events are more describing what the user did in the last hour. These kind of problems are also solved with complex event processing. And of course, this extraction of higher level events might be cascaded. So we might have another higher level events extracted from the ones that we already extracted. And this is extremely important to be able to implement technical concepts like alerting or notification about situations, or trigger any actions in our environment, I would say. But where it is needed in a more business, like I would say in the business terms, there are multiple use cases, but I can list at least a few of them. For example, behavioral marketing, where we would like to analyze our customers' journey, how they interact with our company, and be able to react on their actions. For example, propose their next best action, I would say. But not only that, product analytics, where we would like to analyze how the users are using our products, and for example, where they drop out from usage of our product, which is example of such analysis is a funnel analysis or a path analysis, how users are going through our applications. These kind of analysis actually requires complex event processing. Business activity monitoring, for example, monitoring of the supply chain, right? The supply chain and the delivery of the packages. And be able to react, for example, on the any packages that are being delayed. These require analysis like that. But also other stuff like technical monitoring, that's rather obvious, detecting anomalies in the behavior of the machines or devices. But also fraud detection, where we, this is more advanced fraud detection, where we analyze patterns of the actions that happen over time. And classify some of the, I would say, events or happenings as fraud, as potentially fraud, at least. Just, I wanted to mention that you probably see on the internet, or you met the term of ESP as well, even stream processing. And I would suggest, I just wanted to mention that both are rather now becoming very close to equal. The difference between is really diminishing. Traditionally, SEP was rather single machine, specialized machine with low latency processing, but rather complex processing that is being expressed with a high level language like SQL, not SQL. While traditionally ESP was rather straightforward, high throughput and distributed, right? But it didn't, we didn't solve complex problems with that architectures. The best is that now these two concepts mix together, and we get systems that can do best. They can do both, I would say, which means apply even, solve complex event processing even on a large scale and in a distributed way. I tend to use the term streaming analytics now as a new term, I would say, a little bit modern and fancy, that combines the both concepts into one. All right, now I wanted to just sum up the need for the things that we need to be able to solve stream processing problems with stream processing paradigm. So definitely we need a possibility to solve the cases in real time, because as we have seen, at least as I have highlighted, most of the business value from stream processing is extracted thanks to possibility to process data in real time. But on the other hand, to be able to solve problems with stream processing, not only real time, the systems that we want to use need to be on par with traditional more batch processing systems. So they need to do all the operations that we know from SQL databases, for example, be able to join, to be able to aggregate data. We should be able to reprocess historical data to backfill our data sets, right? But also things that I didn't have time to mention, like be able to do machine learning, especially scoring part, which means applying the models that are being built somewhere else. And very important is the complex event processing part, as this one solves a lot of business problems. And the system that we are looking for needs to, of course, solve these problems on the large scale with a very high throughput and low latency, actually. I'm missing here that. But not losing on correctness or fault tolerance. For a long time, systems were especially giving up on the last one, the correctness or fault tolerance. But now when we want to have one system that is able to replace, I would say, be a paradigm that everyone applies for processing in general, these needs to be, these are, I would say, obligatory now. So how, I mean, do we have such a system now that is able to fill these needs? And I claim that yes. And the system that I suggest and we use in GetinData when we build systems solving the class of problems that I introduced is Apache Flink. It's an open source project, as every project that we actually use in our company. It's an open source one, which I would say it's in a short sentence, it would be saying that it's a processor, a stateful processor over massive data streams. So it can actually scale infinitely and be able to do stateful processing. That's the most important part. It's a project that was started on the university in Berlin in even 2010, but then grew up to a fully, I would say, community-driven open source project. Later backed by a company from the original authors of the Apache Flink, a company called Data Artisans, that later was acquired by Alibaba and became Ververica as part of Alibaba holding, I would say. And it's this popularity of the system is growing enormously. Its applicability to stream processing system got its popularity the most, but now is being applied to, as I said before, batch processing. I mean, to replace batch processing, the traditional one, but also to apply machine learning and many other use cases. So I'm not sure how many of you have heard of this system, but definitely if you haven't, it is worth looking into it. In the further presentation, I will be saying, of course, why it's so worth looking into it. To give a credibility to that system, let me mention companies that use it, from very large digital natives, I would say, or in digital companies like retailers, Alibaba or Uber or Netflix, to banks like ING, telcos from all over the world, and many other companies that you have heard of, I'm sure, or at least most. All these companies have one thing in common, that they have a lot of data and they need to process that and they want to get actionable insights out of it. And they found Flink as a solution for their problems. Of course, we didn't put our logo there, but of course we use Flink. We as GetinData, we use that in several contexts, industries. These are banks, where there is a lot of transactions to be processed. Telcos, of course, where there is a lot of logs or events, I would say, happening in the network. But also manufacturing, more precisely of cars, and ad tech, which is also very data intensive industry. We are also committers to Flink, especially on the CEP, Complex Event Processing library, and we want to be even bigger committers, I would say, right? We want to put even more, I would say, of our passion and power to make Flink better. Why Flink is so good? It's too short of a presentation to tell everything, so I would just focus on few aspects. The most important aspect is that let me first say that one of the very common problem in stream processing is that data that comes to us might come late or out of sequence. I tried to display that on the picture. I hope it's somehow visible what I mean. Something that people who do batch processing usually don't care, because they solve this problem implicitly by waiting enough. While in stream processing, of course, we don't want to wait. So this is a problem that's broke a lot of correctness in systems like Storm or Spark streaming for a long time. And now in systems like Flink, it is being handled by the framework. With use of concepts called watermarks. It's, of course, I'm not going to talk about it, but the most important part is that it is being solved by the framework. We just need to help use this feature of the framework, but generally, Flink cares so much about correctness that it has that baked in. Another very important aspect is how Flink cares about state. So all the analytics that we do require to keep state while doing the analytics. Even in batch, when we are doing batch analytics, there is a state inside of the job that we process. It is mostly memory or being dropped to the disk when shuffle happens. But here, I mean, so it also exists in stream processing. It is used for any accumulation, like summing the numbers and keeping the number, the sum, the partial sum that we already have. It needs to happen somewhere, right? So usually the systems keep that in memory. And I mean, a lot of systems use simply memory to keep that, but that memory is fragile, right? When the job fails or a task fails, this memory can be lost. So other systems also, or we implemented a lot, keeping the state in some database, in a separate database, which of course is resilient. But on the other side, we had to communicate with this database, and that is very, very that deteriorates, I would say, performance. So how Flink solves that? That's by keeping the state local to the computation. So we would say, okay, in memory, yes, partially in memory. Partially, actually, also it can hold it also on disk. But it's there's too many details to say, but I would say that with a very specialized embedded databases, it can keep also data on disk while keeping performance very high. Not so high as with RAM, but still very high. And we are able to, this way, we are able to process events in number of millions per second. The state itself, rather in memory, can process definitely millions of updates per second and core. There are other things that slow down the processing. So of course, we are not getting to millions of events per second in general. But now you would say, okay, so when the job fails, does it lose the state? No. One of the most important things in Flink is that it has baked in fault tolerance. So it checkpoints this state, snapshots it to an external system, and that system is believed to be resilient, of course, like it's a distributed file system. But the most important is that the state, even that it is distributed across multiple tasks and multiple operators, it is consistent. It is in perfect sync, keeping the pointer in the data with the accumulators that state that happened at this data point, at this offset. And what is also beautiful is that this mechanism of checkpointing does not affect much the processing speed. So we can have it, we must have it enabled, I would say, in production, and the checkpointing happens very often. So these are like the most important Flink features that I wanted to mention. I would need to make 4 hours long speech to say about other stuff. So I'm skipping that. But you're probably interested how the Flink job looks like. And yes, it is definitely distributed. There are workers, as in many distributed systems, there are workers that consume the data and produce the data. And there's, of course, a control plane which helps those workers to work. And these workers can be distributed on multiple machines, right? On even hundreds of nodes in our setups. And how do you code with Flink? With many APIs, but starting from a more developer-friendly and more sophisticated APIs that allow you to do even advanced stuff in Java and Scala, through APIs that are more for dedicated for data scientists with Python, up to even using just plain SQL. There's so much push into having fully featured SQL language as a language of definition of the processing. It's extremely important now in the Flink community. Okay, so now just to give you an idea of where the Flink can be applied, right? So definitely if I try to draw a bigger picture and show you that the most important, of course, place where Flink is applied is the stream processing itself, right? Where a lot of things happen that I'm not going to mention now. But also Flink can be used, and we use already, in data collection and data delivery to external systems. That means communicating through APIs to other systems and either collecting or delivering. It's very easy to develop new, I would say, new connectors to the systems that you have currently. And of course, the technology fits very well into whatever you already have regarding security, regarding monitoring and orchestration, for example, whether you use Yarn or Kubernetes. And on top of that, you can build, as we built, and I'm going to tell you, many new features like a mechanism to apply business rules on your data, or define triggers, which are like notifications, I would say, that something happened. There was a question on the YouTube, would you show an architecture diagram with Flink load files to a NoSQL database? Of course, there's no place for such. I hope that this picture can somehow show very high level, but to show it low level, that would be that would require too much of an explanation. But I'm going to have another slide as well on our use case. Okay, so I wanted to spend half of our webinar on just introducing Flink, because I believe it's the most important now. And now I jump to the subject of how we used Flink and other technologies as well in our prominent, I would say, case of from Kazakhstan at one of the largest telcos called KCell to solve their problems. The KCell is one of the largest GSM operators actually in Kazakhstan, with over 10 million people. Very innovative, that produce not only like typical telco products, but of course spanning the services that they do to many other industries or use cases, I would say, right? Including banking and media, I would say, content delivery as well. When they deliver so many services and so intensive, they have tons of data of different types that they need to input be able to process them, and be able to act on them, I would say. Act is here very, of course, generic, but there is the need for marketing, for fraud detection, for automation of the business, everything that I already mentioned. So all of those use cases are actually were needed to solve in KSL when they ask us for help. By the way, they actually already asked us for help 3 years ago. It was already 3 years ago. We were referred by actually the authors of Flink as a very good company that can help implement use cases with use of this technology. The cooperation still is in a very, very good shape, and we are still working with them, delivering more and more value out of the platform that we built. So just wanted to mention a few use cases that when we came, actually, they were on top. That is around, one of them is around marketing, right? About delivering the right message to a user. They have a lot of subscribers that are prepaid, so they need to top up their balance. And some of them top up very often, like several times a week. They spend quite fast their money. So we want to deliver them message that, hey, you actually can, you are paying quite a lot. You can buy a package of auto top up that will, with which you will save some money, right? And your top up will be automatically done when your balance drops to some value. And we would like to deliver this message with a SMS, text message to the user. You would say, okay, but definitely these kind of cases can be solved in batch, right? Why Flink? So because the clue is that this message is most valuable when delivered just after a top up, like an nth top up happened. So I'm referring to the situation where a user still keeps his phone in hand, I would say, or at least have it still in thoughts that he just made another top up. It is proven already in KSL case that these messages, when delivered just after a top up, they are much more efficient than delivered some other time of the day randomly. So we wanted to deliver this message as quickly as we could. On the right side, I just wanted to show you how a possible form for definition of such a trigger could look like. It's not important for now. Other use cases are like roaming. When the user goes to roaming and he registers in another country with some specific network, we have some offer for him. We would like to send him an offer because we have some partnership with this roaming site. And we want to do it fast as well, right? Not the next day, but now. Very important cases are also to prevent fraud. For example, when the users, there are usually the users who go to roaming and have balance equal to 0, they should be blocked. They should not be able to use their phone. But in some cases, they are able to go around it. And if they do, they can bill us a lot of money, so a lot of money until we actually get to know it, because the data about their calls and so on go through the partner and they go late, they get to us late. So we want to be able to react quickly, and when they go to, when we detect such a situation that a user with balance 0 goes to roaming, which by the way is coming from 2 different streams, so this information has to be combined. We want to send a message or be able to even block the number automatically. The other stuff is around notifying the user about things that he cares about, right? So for example, he can define a personalized notification when his balance goes down, or when he spends this and that money, or his bonus balance is already 0. We want to be able to automate business, for example, provide, grant a bonus to the salesman that sell phones when they, just after we got an identification that in CRM that new phone was sold, for example. And another class is the regulatory class of use cases where government actually needs to get information that a blacklisted phone was used. These kind of things are also not only used, but used by some pattern, for example. I mean, I don't know the details, but these are not a simple cases where we needed to detect the situation. All right. Sorry, there was a system that was that existed before the KSL site. It's not that much worth mentioning because it was 4 years ago. But definitely, its main problem was that it didn't work. It didn't solve the problem the way that it was required. So that's why we decided to build a new system. That's why we were asked to build a new system. And that system needed to process really large scale. In the beginning, it wasn't that large, but now after 2 or 3 years, this is the throughput that we are working with 500,000 of events per second even, and over 1 terabyte daily of data. So there is a lot of data to be consumed and monitored by the system we built. So how we finally built the system, we came up with this sketch of the architecture, which is pretty obvious and simple, where we have a layer that ingests the data, puts that in a pipe that delivers this data around the system, around multiple system actually, and we call it Events Hub, where events processing system can look into and be able to consume this data and produce the results. And the results will be delivered to an outgestion or egestion system that delivers this, the notifications triggers to the dedicated systems. You're probably interested what technologies we use to do that. So some of them are obvious, like Kafka for Events Hub, but the most important is that Flink, it was used for events processing. NiFi was used for ingestion and outgestion, and now the core pipelines are being rewritten even to Flink for stability reasons as well. That's not everything. There's a layer of other systems that work together with that. Very important is the security. I would start from the right side, because in such a company like Telco, there is a stringent security rules. So we had to secure the system so that it cannot access the data it's not allowed to. And users cannot access the data that they are not allowed to. And we were able to integrate with Kerberos all the components and all the I would say user systems with LDAP and AD of the company. Monitoring was provided with Loki for logs collection and Prometheus for metrics collection. I'm going to say a word about it later. And important part is also in the middle, which is like a simple UI that has those forms that I showed in the beginning, that allows business people to define new triggers. So they don't code against APIs. They don't code it against Java, SQL even. They just fill the form, click submit, and the new business role is being launched in the system. That was very important part of that system, and I have even some part of the webinar about it. Next, that was the beginning, but after 2 years of this system working in production, we attach and still work on that, attached data lake which collect this information for historical, to keep history and for analytical reasons, for analytical use cases. We also use some specialized storages like Druid for providing BI on top of that history. Okay, that works now. Let me zoom in for a second to tell you that everything is in streaming. So that, data that is being provided even in batch, like files on the file system, FTP and NFS, is being converted to the stream of data with proper timestamps and so on, put into Kafka, and then Flink reacts on that. So it was important that we do that because some of the systems that are now batch will be transformed to streaming, and we were able to already prepare for that. So we have unified all the processing to be streaming first at least. Everything is a stream here. That also even the requests to start a new trigger is a stream of commands as we implemented it this way. Now, just wanted to focus on something that is more for people who already use Flink. So it's more for technical people, some treats. I'll try not to speak about it too long, but I hope you will find it valuable as well. The dynamic rules design. So most of the systems, right, that are Java based and so on, they allow us to only launch applications as separate applications. Sorry, launch rules as separate applications. But here in this context, we wanted to run even hundreds of those triggers. Sorry, not wanted, but really that happens. We already have 150 of those business rules of triggers running on our system. So how do we do this? Do we run a job per rule? That is extremely resource intensive. That at least it's around intensity of using CPU and RAM for just jobs, but also for pulling data from Kafka, because every job pulls the data independently. The state also, the features that are being used by those triggers are also being replicated. So that completely ruled out an idea of running every trigger as a separate job. Our approach was to actually run one job that could accept all those rules and be able to, apply all those rules in a single stream. That is something that isn't like allowed out of the box by not only Flink, but no actually framework. No Flink, not Flink, not Spark, not Storm, definitely. And this is really I would say, something that is not being addressed fully by at least open source market, of course. I'm not talking about commercial market. So what we did is we provided templated jobs, the triggers, I would say, already implemented, but they accept the configuration, and we are able to spawn multiple of those templates, right? Instances of the trigger with different configurations, and be able to run hundreds of those rules efficiently. We can add those rules and remove those without restarting the whole job, the application that runs those rules. A little bit zoom in into how it looks inside, where our job is actually, our job does several things inside of that. It accepts multiple streams of data. It needs to sort the data by time because complex event processing requires data to come actually by time, ordered by time. It actually also deduplicates events because there are events that are being duplicated in the stream. And then there is a router component that routes the events to specific trigger instance, because it knows from the control topic which trigger is interested in which data. There is also some, let's say not triggers, but we call them state updaters that are producing state like features. For example, a balance of the user, current balance of the user, that can be used by multiple triggers so that the state is not being replicated. Okay, I need to speed up a bit. That I already said what is the pros and cons. I hope you already got the idea. But sorry, especially pros. But cons, the problem is that we are not able to use high-level APIs that are being implemented on Flink. For example, SQL. We need to re-implement that if possible. It is also tricky to debug, but we can say that we already solved a lot of those tricky stuff with proper coding, I would say. So there are, of course, cons of this design, but we managed to, I would say, to overcome some of them, except, of course, the high-level languages. But we are working on that too, to be able to use SQL to define the rules and still keep the dynamic rules design. Okay, that I will skip because that's another detail. So we hope that Flink at some point of time will actually, in core of Flink, will support cases like dynamic rules design. It will allow to schedule dynamic topologies and use dynamic SQL. We already spoke with the community, with the Ververica team about that, and they are looking seriously at that need because it's definitely not only ours. Okay, the important part is that what is to give you some lessons learned that we had, or the decisions that we made, because you might have the same decisions to be made in your environment. So I wanted to share about that. So we needed to deliver powerful and real-time analytics, right? From day one, we decided that we were going to go streaming first. We definitely believe that technology is ready now to deliver streaming first analytics, avoiding batch as possible. We use Apache Kafka, but that's rather obvious. And of course, we use Apache Flink, which I already said why. To deliver the highest possible performance, we use binary format for keeping data that is called Apache Avro. It's a very efficient format that is being used extensively in big data worlds. I definitely suggest looking into that, not use JSON or CSV or other formats that are text-based. Of course, you're losing readability, but on the other side, the performance gain is enormous. The keeping the state local was also like very important. Is a very important part of that performance profile. Thanks to that, we are able to process hundreds of events per second. And by the way, it's not only about the moment that data flows in hundreds of thousands of events per second, but there is a lot of moments where you need to stop the job and start it only after, I don't know, 15 minutes. Of course, you want to start as quickly as possible. And then there is a backlog of data, and it is very important that your job process this backlog as quickly as possible so that it is on the top of the data. So this performance possibility is extremely important in such cases, especially. That would not be possible with external databases to keep the state. The ease of use was extremely important for our client, for KSL, and we used NiFi to be able to quickly deliver data ingestion pipelines. They allowed us to define by not only by Java coders, but also other team members, I would say pipelines that deliver data into the system, but definitely we don't use it for SEP. And I strongly suggest not doing that, because expressing complex event processing in NiFi, analytics in NiFi is tedious, definitely tedious, and error prone. It's hard to keep the correctness, I would say, of the processing. We keep the web UI, of course. We deliver the web UI for configuring the triggers, because that was also important. We delivered reliability with use of already proven technologies, run Flink on Yarn, and have, of course, strong monitoring and logging. Of course, having very strong security was also a no-brainer. We needed that. There was nothing to think about. We designed the technology, the platform to be very extensive, and that was very. We used a lot of components, loosely coupled components that can be easily replaced or connected to other components, and thanks to that, we were able to extend the platform. And of course, cost efficiency was also a very big point. We weren't allowed to buy hundreds of machines. We actually had to start with five machines on that scale. And believe me that we did, and we succeeded in that with careful, I would say, design. We used HDP as a license-free distribution. Now there is no HDP license-free distribution, I know, but we have some answer for that as well in GetinData, by the way. If you are interested, also we can talk offline about that. We put a lot of effort into testing. We defined a framework that allows us to create tests in a very declarative way and test them end-to-end before actually delivering the results to production. Our collaboration was extremely successful with joint development team, where our team, GetinData and Kaisel, worked together as one team. There was no barriers between us, I would say. One Scrum team. Where client learned a lot and very fast from us about technologies, and we learned a lot and fast about the domain. Testing, of course, was a no-brainer. Code quality was also on a very high level. Knowledge sharing was delivered thanks to this joint development. And I would say we delivered, thanks to all of these practices, we delivered the system very quickly. We started in September, and in January, it was already in production on the first case. And it exponentially, the number of triggers started to grow. And now it is, and it is very, very important to share that ROI, return of investment in that system was very high. I think that in half a year the cost was covered, thanks to the gains from all the campaigns running on it. 3 years now, and it's still a very important piece being extended still. All right, that's all I wanted to share. I hope that everyone can stay for a few minutes for questions. I'm going to look at the questions now. You said core systems are written in Flink for stability reasons. Is that porting from NiFi to Flink? So core pipelines were written to Flink. Yes, exactly, because we had I would say a lot of problems, and we still, I mean, it's not only our problem, it's definitely the community problem with getting, I would say, pipelines on NiFi right, which means not to lose data in case of any failure of Kafka or the source system. Right, which means also not reorder data in a very weird manner. And also to keep the NiFi stable on high load, because the NiFi can quickly crash if there is a really high load on the system, and we have quite high load. rewriting them to Flink allows us to keep the, of course, very high performance, stability, the correctness of the results, because the stream, thanks to checkpointing mechanism, that gives consistent state with the offset on the Kafka, and I would say transactionality of the processing. You can call it transactionality of that processing. We don't lose data in the end, right? We keep the correctness. There's a question around certification into Flink. I'm actually not. I mean, there are trainings. There are trainings given by a few companies, by Ververica as the first, which are the commercial companies behind it. By us as well. We do it occasionally. For example, when doing Big Data Technology Summit in Warsaw. And I believe that there are other companies that are also doing this. There is a question, is it possible to program Flink with Python? Yes, it is. With Python, we have a high-level API that is like Spark dataset API. Yeah, exactly. So it allows us to define declaratively what we want to process. It is also possible to define UDFs in Python and so on. There is also very strong now library called Beam, Apache Beam, that allows us to code on any of the runners, actually, not only Flink, but also Spark or Dataflow in Google Cloud Dataflow, the same code, to run the same code on any of those systems, and also that provide Python API. I would say the strongest. This is now the suggested solution, actually. So yes, it is possible. Is it possible to use? Is possible to use development Flink in Google Cloud in Dataproc? So in Dataproc, yes, it is possible to use Flink in Dataproc. It is available there as one of those add-ons. Also, you can use Beam API, as I said, and be able to run on Google Cloud on Dataflow, or on Google Cloud on Dataproc on Flink, or on premise Flink. So you can code once and run it anywhere you would like. I'm not saying it costs anything. There is some performance penalty when using Beam, but in a lot of cases, this is an acceptable cost. Would you recommend use Flink in on-premise, cluster, or cloud? Both, both actually. On-premise, I think that there are no open source systems that match superiority, I would say, in manner of like understanding streaming problems. In cloud, there are systems, of course not open source, but there are systems that are I would say, yeah, there are as powerful as Flink, especially Google Cloud Dataflow, which is the friend, I would say friend, let's say, not a foe of Flink. They borrow from each other a lot on the design, and definitely they can realize the same use cases. There is also Flink on Amazon, right? On EMR, it's available as an add-on, and there is even a managed service on AWS. Kinesis Data Analytics for Java, I think. It's a weird name, but it is there. There is no such system to my knowledge. I'm not saying for sure on Azure. Okay. Now getting to, could you please talk a little bit about how did you avoid data loss or duplication? Do you rely on Kafka exactly once guarantee? No, we did not. On exactly once guarantee of Kafka, no, we did not. We allow, first of all, regarding data loss is being, I would say, guaranteed by Flink checkpointing mechanism, right? So that when it collects data from Kafka, it checkpoints regularly the offset to which it processed the data and the state of the accumulators together with that offset. So if anything bad happens before the checkpoint, right, we will restart the job from the last checkpoint, which is somewhere in the past, a little bit in the past, I would say, a few seconds probably. So there is no possibility, almost no possibility to data loss. There are really, like, if some cosmic rays shoot us, there might be a possibility for data loss, but we're not considering these cases. Regarding duplication, what we do is we design our system to be effectively ones, I would say. There is a possibility for having duplicates, but our systems are ready to accept duplicates and ignore them. So in the Flink application, as I was mentioning, the job was deduplicating. When it saw the same event ID twice, it redirects one. And also the results, when they were delivered to external systems, the external systems also allowed for duplicates and rejected an event that was a duplicate. That's generally the rule of creating effectively one's architecture via idempotency. What was the biggest challenge during writing tests? Is it difficult to test applications created in Flink? No, actually, there is there's a test harness in Flink that allows us to test Flink. I would say to unit test Flink and end-to-end test Flink, to write integration tests. So most 90% of our tests we're running in IntelliJ via JUnit, simply, and of course in CI/CD. But for the really, like, complex cases that require, and not many, because you cannot write many end-to-end tests, we were writing it like full tests that were running on a pre-production environment. I suggest there is a presentation from Gyula Fora as well on the Flink Forward about testing Flink applications. I suggest watching it if you are especially interested in this subject. Should the data be binary? You mean, no, definitely not. The data that comes in to our system were usually CSVs or XMLs or JSONs when they were accepted to the system. But we converted them to the binary, and they were stayed in the system binary for performance reasons, right? Because we accept, of course, there will be no sense into converting to binary if we process it once, but we process the same data multiple times. So it is worth converting that to binary once and then apply multiple rules on top of it, and also store it in the data lake in a binary format, in a very efficient, actually, not even raw format, but actually columnar format, because it's more for analytics. Yeah, the answer could be much longer, but I'm trying to not to go too deep. I hope I answered this question. Any more questions? Okay, there is a question. No. Yes, there is a question. It's just somehow intermingled. Could you talk about debugging Flink runs in when Flink runs in production, especially around Flink node or job crashes? So I would say typical ways of debugging applications apply here. Definitely, you need to collect metrics to know how the job performs and when, you know, lag is growing and so on, to actually be able to be alerted, I would say, on the errors. You need to collect logs, aggregate logs from, because this is a distributed system, as many now, you need to collect from the nodes the logs and keep it in a single system. A lot of people solve it with Elasticsearch stack. We already solve it with Loki. That comes from Grafana Labs. Definitely, I recommend looking into that system. It's for logs itself. It's really, really efficient. It allowed us to make the cluster from 8 nodes to 3 nodes for keeping the logs. But there is also one thing that we also added, which I didn't talk about, to our system, which is around more like business debugging, where people wanted to know from the marketing why this trigger did not launch when I believe it should launch, right? Because my rule said that yes, it should launch, but it did not, right? We did not deliver the message to the customer. We implemented a mechanism we called tracing. That means every step of processing of a single event and the aggregate of the event and so on logged an information about that this step happened. And it put it in a single timeline, and we were able to ask the system, hey, can you show me what are the logs, right? The steps, the traces for this user, this particular user that I'm interested in, and this particular time span, right? And show me how this event of, I don't know, a top-up event was being processed by the system, right? What happened and which rules were applied on that top-up. So we had to implement that. And it's an interesting fact that this system, for each of the events out of 500,000, it generated 10 logs, 5 to 10 logs. So out of 500,000 events per second, we had to build a system that needed to process 5 million events per second. Thankfully, not the same complexity of the processing. We had to just store it in this file system, but still, it shows the complexity of the solution. There is a question. Can you somehow have dynamic windows in Flink based on side inputs, triggers? A rule trigger would rely on data in past n days, with n being defined by a trigger. Yes, you can have that. It requires this special coding. I would say that we actually implemented this dynamic rules design, but yes, you are able to. There is a possibility to have a, I would say, Flink is very pluggable, so we can actually write your own window assigner, it's called, which says that for this event, assign this many days of window, and it can be dynamic. It can be based on the rules that come from outside. We did something very similar in our case, by the way. Would you apply CDC with Flink for incremental data? Oh yes, definitely. We do that. I didn't like show it here, but from some of the databases, we actually pull data with, not a fully featured CDC. We do it with SQL based on a modification time column. We select events that happened from the last pool of the data. But definitely you can just process CDC that is being generated by Debezium, for example, right? That runs on Kafka Connect. We do it in a different context, not in this client, but in different client and with different client. What is even more, in the next version of Flink that is being released very soon, Flink is going to have even native support for those CDC logs. In a very sophisticated manner, it can create tables in SQL that reflect the data that comes from CDC. So it's a really, really nice feature we are waiting for to define our processing, I would say, our ETLs based with SQL on top of CDC data. So I hope that I answered the questions. Regarding the tests, I did answer. Okay. I think no more questions up to now. All right, I think I will wrap up. Oh no, there's another question. Would you compare Flink with Cloud PubSub? No. These are like component which is active Flink or Google Cloud Data Flow and passive Cloud PubSub, Google Cloud PubSub, or Kinesis or Kafka. These are systems which are rather passive. These are only buffers that accept the data and serve it when someone asks for it, but they don't process the data. Would you compare? Oh, sorry, that was already answered. Okay. No more questions. I just wanted to maybe say the last word is to recommend you to look into this into Flink technology, and stream processing itself. Believe me, the world is ready now with open source technologies to be able to do with stream processing almost all data processing, from collection through transformation, sophisticated ETLs, and deliver them to external systems, even in much easier way than with batch, thanks to no batch boundaries and a possibility to express everything with SQL. Definitely look into that. And of course, we at GetinData, we are proponents of that. We already are experienced and work with these technologies for several years, not many, but several years, with people who have experience in that went through the history of those systems, especially including me. I definitely recommend you to ask us questions and reach us if you need help. Okay, as we are still on the call and people are maybe still there, there's one more question regarding using Flink on Kubernetes. So yes, definitely, in this setup we used Flink on Yarn because that was 3 years ago. But now we in our recent systems that we built, we use Kubernetes as a scheduler. We don't use Yarn anymore. So definitely I recommend running Flink now on Kubernetes, especially if you don't have Yarn. If you have Yarn, yes, you can think about it. But if you don't, then Kubernetes is the way to go. Okay. That was a bonus question. Thanks, everyone. I hope you liked it, and subscribe to further webinars coming from us, and definitely come to, if you are somewhere in Europe or not, you're not even, we have guests from all the world, come to see us in the Big Data Tech Warsaw Summit in February, still half a year, and reach to us. Thanks.